the kind of the study of lake ice on Lake Superior, is that similar to Arctic ice?
That's a great question. It's something that we've played around with, and we haven't really followed up on this. I need to spend time talking with people who actually work in Arctic systems. The idea here, she's asking whether there's anything to be learned about how the Arctic works, and I would hypothesize that this is one of the really direct observations of a strong impact of changes in ice cover on the temperature of an aquatic system. The Arctic is a big, and it's really difficult to get to, and you have to worry about salt, it's a complicating factor in things. Sure. And it seems like Lake Superior is a sort of like a case study, but we haven't really followed up on that thread. So
it's kind of a similar topic. Last week I was in Thunder Bay, Lake Superior. Thunder Bay is still frozen and you can still walk on it.
Right.
Does it affect that this lake has, which is one piece of mass water, nor is still frozen and south is
right. Well, we see these trends towards lower ice on the lake, and eventually, if things continue the way they are, we're going to get to a stage not where there's no ice ever on Lake Superior, but when we have lots more years when there are no ice, and lots fewer years when we do have significant ice on the open lake. Places like Chequamegon Bay and Thunder Bay and Whitefish Bay, these fringing shallow bays, they're so heavily iced over that the changes in climate that are predicted aren't going to cause those sorts of things to not have ice. So in those cases, the important thing there is that when you're out in the middle of the lake, you have a lot of water that you have to cool off in order to form ice at the surface. Whereas if you're in a relatively shallow bay or you're in a smaller lake, then you don't have as much water to cool off, and ice sets in a lot earlier. So it's just a lot harder to make that go away.
Have you found in your research that maybe a large ice year is followed by another large ice year due to the point that the lake doesn't have as much time to heat up?
Yeah, so this is a great question. Is we've established this, what we believe to be a causal link between conditions in the winter and conditions the following summer. The big question, sort of what you're asking there is, well, so does the summer then, does summer 2010 affect winter 2010, 2011, right? Does that affect carry forward? And I did a comparison similar to, can I scoop this thing on? We have this comparison here, where there's this clear relationship between ice cover in the winter and the following summer water temperature. That's a pretty strongly established one. I did the same plot where I took summer water temperature and plotted against the next year's ice cover, and there's no relationship whatsoever. And that's sort of interesting. I mean, I don't understand. We're still working on developing a strong understanding of why the connection doesn't work in that case. And I think it has a lot to do with the fact that those fall storms that drive the cooling tend to be a lot more vigorous than the warming. The warming tends to be pretty uniform. And I think the lake is driven towards that equilibrium a lot faster in the transition from summer to the following winter. And so you don't see sort of a memory effect in that connection. So, but yeah, it'd be really interesting if we could show a link between conditions one winter and conditions the next winter, because then you start talking about feedback loops and stuff like that. It's really interesting.
So I know you're basically working a lot on the temperature and then maybe some of the ice cover. Is there any interest in kind of the weather changes that will happen around the lake due to decreasing ice cover? Because I know, especially locally, the lake has a huge effect on, depending on what side you're on,
right.
The lake affects snow versus warmer, cooling in the summer, warmer in the winter. Is there anyone looking towards?
Not that I'm, not explicitly that I'm aware of. I mentioned briefly that I had a paper a couple years ago where we showed that wind speeds over the lake
Right.
were increasing, and the reason there is that, let's say, these are the winds aloft that are actually being driven by pressure systems in the atmosphere. And these are the winds we actually measure at the surface. If you have very cold water, the air next to that is relatively cold, and you have a big density difference between the warmer air aloft and cold air right at the surface. And it turns out that when you have a big density difference like that, it's relatively easy for this stuff to slide along without dragging this along quite as much. Okay, and we could get into something called stratified turbulence theory. We don't really need to go there. The point is that when these density differences are big, it's difficult for momentum aloft to be transferred down to the lake. On the other hand, if the lake surface is relatively warm and there's not much of a density difference between the winds aloft and the winds at the surface, then it's a lot easier for those winds aloft to drag along the air at the surface. And so we see when we warm up the water without warming the air up nearly as much, which is what we've experienced, that that we have these higher average wind speeds. What's really interesting is that we've seen these trends in wind speed at all these open water buoys. We don't see it at terrestrial wind speed measurements. So we have coastal measurements, and we don't see that trend, which tells us that it really has something to do with being on the lake, rather than it being some larger scale meteorological system. As far as understanding the impact on the region around the lake, it's a great question. It's something that I've been sort of hawking. There's a group that meets up at Wolf Ridge once a year. I don't know if anybody here is involved in that with the phonology conference with Peter Harris.
Yeah.
Okay, were you there last year?
I was there the opening night this year, but I had to work here, so I
and I think I
was
missed
there
the
for
opening
the
night this
yeah.
year. So, but I've been talking with Peter about the idea of looking at terrestrial phenological indicators, blueberries or lilacs or whatever, and seeing whether there are links between those and the very, very clear interannual variability in something like ice cover, and summer water temperature. Because it'd be really neat to see those sorts of links, but we haven't followed through on that.
You mentioned at the very beginning about ice, the sediment coring and that kind of thing, and we've had two presenters that have talked about sediment cores so far in this series. Has your data been used to correlate to sediment coring? And
sediment coring tends to be on relatively long scales, and the instrumental record at Sault Ste. Marie goes back 100 years, and that's considered an extraordinary time series. There are not very many. I think there's literally like 2 or 3 longer time series in the world, not just in lake systems, but in marine systems as well, that have like that daily measurement that goes back over 100 years. There's one in Woods Hole, for instance, that goes back 105 years. Whereas the sediment cores, it's very difficult to resolve stuff at annual scales, especially right near the surface, where things tend to still be being biologically acted upon and stuff like that. So we've talked a little bit about that, but we haven't really done anything like that. It's hard to do. Anything else? Okay.
Well, thank you very much, Jay. This is